Hello, this is Wendy Lightheart, and for this lesson we're going to learn how to use proportions to solve application problems. You may be wondering, what is a proportion? So let's start by defining what a proportion is. A proportion is an equation that states that two ratios are equal to each other. For example, this proportion states that the ratio of 26 to x is equal to the ratio of 42 to 5. Let's go over the steps of how to solve a proportion for a variable such as x. The first step is to set the cross products equal to each other. The cross products are found by multiplying diagonally across the equal sign, which we'll demonstrate later. The second step is to simplify this new equation on both sides. Then the third step is to solve this new equation using the skills we've learned so far for solving linear equations. Let's see how these steps can be applied to solve a couple proportions, and then we'll look at some application problems. To solve this proportion, we first find the cross products, which we find by multiplying diagonally across the equal sign. So one of the cross products of this proportion is 5 times x. The other cross product is 6 times 8. Now we don't usually write these results off to the sides like you see here. This is simply to demonstrate how we multiply diagonally to find the cross products. Once we find the cross products, we set them equal to each other. So we put them on either side of an equal sign, in other words. And we do this below the original proportion. Then our next step, remember, is to simplify both sides. And our last step is to divide both sides by 5 in order to finish solving for x. Thus we find our solution of x equals 48/5, which we could also write as a mixed number, 9 3/5, or in decimal form as 9.6. So what form you want your answer in will depend on the context and what you're being asked to do. Let's look at another one. Our first step, remember, is to find the cross products and set them equal to each other. So this gives us 2.1 times 1.8 is equal to 3.6 times y. And note that it doesn't matter which side you put each of the cross products as long as you set them equal to each other. So now we're ready to simplify both sides. And lastly, we divide both sides by 3.6, which gives us a solution of y equals 1.05. Now let's look at some application problems. For this one, we are mixing medicine, and we need to keep the same ratio of water to medicine, no matter how much we're mixing. The problem states if 5 ounces of medicine must be mixed with 8 ounces of water, how many ounces must be mixed with 36 ounces of water? So first, let's let M represent the amount of medicine that needs to be mixed with the 36 ounces of water. The important thing to note here is that the ratio of 5 ounces of medicine to 8 ounces of water must be equal to the ratio of M ounces of medicine to 36 ounces of water, because the ratio of medicine to water must stay the same. This is why a proportion is an appropriate use to solve this problem, and that's because a proportion states that one ratio is equal to another. Thus, one way we can write our proportion for this problem is to put ounces of medicine on the top and ounces of water on the bottom. We We then make sure that the 5 and the 8 make up one ratio, and the unknown amount of medicine M and the 36 ounces of water make up the ratio on the other side. Now we can solve this proportion to answer the question. So remember that the first thing we do is set the cross products equal to each other. Then we simplify both sides. And then we need to finish solving the equation. So for this one, we just have one more step, and that is to divide both sides by 8 to isolate the m. So when we perform that division, we get m equals 22.5. So we know that 22.5 ounces of medicine will be needed. Now don't forget to put units on your answer. It's very important that you give an answer as 22.5 ounces and not just 22.5. The last type of application problem we're going to look at has to do with similar triangles. Two triangles are said to be similar if their corresponding angles have the same measure and the ratios of the lengths of corresponding sides are equal. Note that the underlined part of the definition tells us why proportions are useful in these type of problems. Because remember that proportions say that two ratios are equal to each other. Let's determine which sides of these two triangles correspond to each other. As you can see by matching up the corresponding angles, the side of the smaller triangle that is marked with an A corresponds to the side marked with an X from the larger triangle. Also, side B corresponds to side Y. And lastly, side C corresponds to side Z. Now, since we know the ratios of the corresponding sides must be equal, we can write a few proportions to state these equalities. For example, the ratio of A to X must be equal to the ratio of B to Y. Another proportion we can write is that the ratio of A to X is equal to the ratio of C to Z. And lastly, we could say that the ratio of B to Y is equal to the ratio of C to Z. So again, we're just stating that the ratios of the lengths of the corresponding sides are equal to each other, and that gives us a proportion. Let's look at how to apply this principle with an example. In this example, notice that we have two triangles, one of which is overlapping the other. And because these two triangles are right triangles and they share an angle, that means that all three angles must be the same measure, and that makes them similar triangles. Whenever you have this type of picture where you have overlapping triangles, it is often easier to solve the problem if you first separate the two similar triangles that you're working with. So now we need to put labels on the sides of these two separate triangles by looking at the original picture. The height of the blue triangle is 10. And notice that the base of the blue triangle has two portions that are marked on the original picture. One portion is marked with X, and then the rest of that side is marked with a 5. Thus, the base of the blue triangle is the sum of those two lengths, so we get X plus 5. Now the height of the pink triangle is 4, and the base of the pink triangle is 5. Now that we have our sides labeled, we're ready to set up a proportion to solve the problem. So we can start by writing the ratio of the heights of the two triangles, which says the ratio of 10 to 4 is equal to, now on the other side we'll put the ratio of the bases, which is x plus 5 to 5. Note that the numerators on both sides are lengths of the sides of the blue triangle, and the denominators are both from the pink triangle. It's very important that both sides are set up exactly the same way. Are you ready to solve? So remember, the first step is to set the cross products equal to each other. And note that when we multiply the quantity x plus 5 times 4, we must put the x plus 5 inside parentheses to show that multiplication properly. Now we simplify both sides, which means we distribute the 4. And then we're going to subtract 20 from both sides to get the constant terms on the right, which will be on the opposite side of the variable term that is on the left. Lastly, we're going to divide both sides by 4 to finish isolating the x. And this gives us a solution of x equals 7.5. Now if these side lengths were marked with units, we would need to put units on our 7.5, but we did not have units on our original picture, so we don't have to worry about it this time. It's always a good idea to also look back at the original picture and to just make sure that this length seems reasonable when you compare it to the other sides. Well, that's it for now. Have fun solving!